Thank you for joining our first webinar in 2017. My name is Hui. I'm data scientist at DuPont Pioneer and program chair of ASA Statistical Marketing. ASA Statistical Marketing will hold a series of online workshops about data science. Today, we have Dr. Bart Bosson to talk about big data analytics and some applications. Dr. Bosson is a professor at the University of Leuven and a guest lecturer at the University of Southampton. He is the author of the book Analytics in a Big Data World. He has also co-authored many great analytical books. Just a little housekeeping before we get started. You can go to scientistcafe.com for our current or future webinar information. If you have any questions during or after presentation, you can use the live chat function on YouTube. You have to sign in your Google account to be able to do that. Or you can send your question directly to me. That's the email address. For those who have already sent me questions, thank you very much. I will ask them in the end. We will have some time for questions in the end. Now I will turn the time over to Bart.
Cool. You guys see my presentation now?
Yep, perfect.
Okay, perfect. Okay.
Can you do full screen? Oh, it's full screen now. Can you do full screen?
Is it okay? Like this?
It's small.
Small. Hang on. Hang on. I don't know how to do this.
Yep, perfect.
Better?
Yep, perfect right now.
Okay, good. Okay, good morning, good afternoon, good evening, or good night from wherever you're joining us. Welcome to this webinar, Putting Big Data and Analytics to Work. My name is Bart Baassen, so I'm a professor of Big Data and Analytics at the Catholic University of Leuven, which is a city which is located in Belgium, and which is where I'm based right now. So right now, at my hometown, it's about 3 p.m. in the afternoon. Leuven is known for a couple of things. It's known for having a very good university, which happens to be the place I work, but it's also known for lots of other things, such as beers, obviously. Belgium is well known for beers, and we have a very well-known brewery, which is called AB InBev, which is about 1 kilometer away from the place I'm sitting right now, and which brews all kinds of magnificent Belgian beers, including Stella Artois, Hoegaarden, and so on, that some of you may have heard of or even tasted earlier on. Unfortunately, this webinar is not about beers, but it's about big data and analytics. So let me continue on that topic first. So I studied at the Catholic University of Leuven here, and I did a PhD in developing intelligent systems for credit scoring using machine learning techniques. I currently still work on credit risk analytics quite a bit, although I have expanded my research horizon to also tackle other related application fields like marketing analytics, like fraud analytics, social network analytics, and so on. If you want to have an overview of my research topics, you can go to my website, dataminingapps.com, which you can see indicated at the bottom of the slide. You will find lots of free stuff on there related to the things we do. I have all the PhDs of my former PhD students available online. You will also find my PhD available online. I may not recommend you to read it maybe, but anyway, you may want to have a look if interested. You can also connect on YouTube, Facebook, and Twitter with my group Data Mining Apps. You can unfortunately not connect on LinkedIn. The reason being is because I have exceeded my limit of LinkedIn connections. Apparently, despite living in this era of big data and analytics, LinkedIn only allows around 30,000 connections, and I cannot accept any more unless I would kick out some of the recruiters, which I plan to do in the next few months. So my research team is all centered around big data and analytics. As I mentioned, credit risk analytics, fraud analytics, marketing analytics. And part of the webinar today will be to give you some overview, some guidelines about recent projects that we have worked on in collaboration with firms. Because we do all our research, obviously, in collaboration with firms. I also published quite a bit of books on the topic of big data and analytics. My most popular book is the one that you can see here in the upper left corner. We sold about 5,000 copies of that book worldwide right now, I think. There's also a Chinese version, which is next to it. And I also have other books, Fraud Analytics. This is my most, this is a book where I discuss the usage of descriptive, predictive, and social network analytics for fraud detection. That could be insurance fraud, it could be credit card fraud, it could be any type of fraud. I also have 2 books on credit risk management and analytics. My most recent one is the one in the lower left corner, which is Credit Risk Analytics, which came out in 2016. The one in the lower right corner is the one that we are working on right now. So although you can already purchase it on Amazon if interested, it is not ready. We still have to write 1 or 2 chapters in order to have it completed. So maybe don't purchase it yet, even if you're interested, because who knows, we never complete it. But anyway, I do hope we complete it. Okay, so to set the stage for this webinar, I just want to have a look at the various types of data that are being generated along the diversity of channels which customers are using to interact with your firm. If you look at a customer, for example, he or she can interact, first of all, via your email, via your website, via email, or via your mobile app, right? So as soon as a customer logs onto your website, he or she leaves behind a massive amount of data, specifying what pages the customer visited, specifying what keywords the customer has entered, for example, in Google, specifying where the customer left on your web page, and so on. But besides using web data, you can also look at your transactional databases. So as soon as a customer makes a purchase or initiates a transaction, all kinds of information about the transaction is being stored, like the location of the transaction, the timing of the transaction, the items involved in the transaction. Think about products or services purchased and the corresponding price, right? We also have call center or service center data that gives you an immediate contact point with your customers, such that customers can call you, ask for information, or maybe even file a complaint. Survey data is another important source of data, and I myself am not a very big fan of surveys because these days we're being flooded with surveys, but it is an important data collection mechanism. And then we have data from partners, and I understood that there's quite a bit of a big group of people that attend from the US, and in the US, you guys are very good in terms of data pooling because you have quite a bit of data pooling firms that are active in the US. Think about firms like Dun & Bradstreet, think about Equifax, Experian, TransUnion, Nielsen, etc. These are all examples of data poolers that gather data from various sources, clean it up, build analytical models on it, and then sell the results thereof to interested counterparties. So this is why we call the era we're living in big data, because these various data generating processes generate a tremendous amount of data, big data. And big data is characterized in terms of its volume, in terms of its variety, in terms of its velocity, right? And in terms of its value, because the value is very important. At the end of the day, you aim to get value out of this big data source using analytics. And here you can see the analytics process model summarized from a bird's eye perspective, because the first thing you have to do when you start your analytics is to identify the business problem. And that could be anything. That could be detecting churn, that could be detecting fraud, that could be customer segmentation, and so on. It is really important, if you do analytics, that you start from a business problem. Once you have identified the business problem, say you want to detect fraud, for example, you can identify all data sources that could be used to tackle that business problem, right? So you can think of socio-demographic data, you can think of claims data, you can think of, for example, in an insurance setting, of claims data or car-related data and so on. So the golden rule in this identify data sources step is the more data that you can identify that could potentially be relevant in your analytical exercise, the better. And once you have identified those data sources, you're going to bring them into a staging area. A staging area is a kind of, think of it as a data mart or a data warehouse where you gather all data and where you try to get a comprehensive view on all the data available for your analytical exercise. Obviously, this data will never be perfect. It will be contaminated with data quality issues. And when we say data quality issues, we're thinking about missing values, like somebody's age is lacking, or it could be outliers, like somebody's age is 200 years old. Could also be inconsistencies in customer names, because typos have been are available in your customer name. So you have to also deal with those. That's why there's a very important subsequent step, which is clean the data. Cleaning is a very important step because you're going to get rid of any inconsistencies or imperfections in your data. We often indicate the importance of this cleaning step using the GIGO principle. And GIGO stands for garbage in, garbage out. It means if you mess up your data preprocessing or your cleaning step, then you can never get good analytical models, not even with the best tools available or not even with the best skilled data scientists available, right? Hence the importance of this whole data cleaning step. The next step is also very important, and that's to transform the data step. And I will come up with another name for that. I will refer to that as feature engineering. What you do in feature engineering is you define features that could be relevant to your analytical exercise. As an example, age is a feature, right? Companies store the birth date of their customers or of their employees or whatever entity they would like to analyze. And based upon the birth date, you can then define or calculate age. Age is a feature as you derive it from a basic data element, birth date. But there exist other types of features that you can think of as well, right? In marketing, we often use the RFM features. R stands for recency. How long has it been since the customer made a purchase? F stands for frequency. What's the frequency with which a customer purchases at our firm? A customer purchases, for example, on average, 5 products a month. M stands for monetary value. That means what's the average monetary value of a purchase? Those RFM features are not readily available in your data sources as such. You have to distill them and you have to create them. And then you can use them to do customer segmentation or maybe even churn prediction or response modeling in the subsequent step, which is the data mining or hardcore analytics step. So in the hardcore analytics step, you're going to build an analytical model, which is going to segment your customers, which is going to detect fraud, which is going to detect churn, or which is going to differentiate the responders, the ones that will respond to your marketing campaign from the non-responders. And various types of analytical models can be used for this purpose. The most popular ones being linear regression, logistic regression, decision trees, neural networks, and random forests. And each have their pros and cons, which we will say a few things about later on in this webinar. And once you have these analytical models estimated, once you build them, you will interpret them. Interpretation is really very important because in the interpretation step, your business expert will tell you whether the analytical model makes sense, yes or no, whether it's in line with their business experience and with their common sense. And the interpretation step is really very important to generate trust in your models, because if you cannot interpret something, you will not use it, right? So interpretation is really important as a crucial step to generate trust in your analytical models. Besides the interpretation, we will also evaluate the models. And finally, the models will be deployed in your business processes. You will come up with decision support systems or any type of expert systems or intelligence systems to do credit scoring, to do fraud detection, to do churn prediction, etc. That's the aim of the whole analytics model. You can see it has various steps going from pre-processing to analytics and to post-processing. Those steps are typically performed iteratively. That means that during your analytics step, it may well be that you have to go back to your pre-processing step to try out some more data, or maybe to define some features. Here you can see various types of applications of analytics, and it's not an exhaustive overview, but it's just a set of applications that we've been working on. We've been doing quite a bit on social networks for fraud detection. We've been working on churn prediction. We've done quite a bit of work with telco providers to help them detect which are the customers that are likely going to leave them. We did that using all kinds of social information about who their friends are, but also about their calling patterns. Currently, we're doing some work on customer lifetime value estimation. We've worked on response modeling, customer segmentation, and one of the areas that I haven't listed in here, but which is obviously also very popular, is credit scoring. Think about, for example, in US, FICO scores. Building FICO scores is a very nice example of an analytical modeling exercise. So you can see big data and analytics are all around these days. There are so many applications of it, hence the interest. Now, what is an analytical model? So I'm not sure whether all of you are familiar with analytical models, but here you can see an example of a very simple analytical model. At the top of my slide, you see a data set, which has 4 customers. Hopefully you have more, but we start with 4. Each of those 4 customers is characterized by means of 4 variables. The variables can also be referred to as predictors. In this case, our predictors are features like age, which has been derived based upon date of birth, recency, frequency, and monetary, which are the 3 marketing features we referred to earlier on. In this data set, we also have a target indicator, churn. Churn is going to indicate whether somebody left the firm, yes or no. This data set is a historical data set. That means that it tells us who of our historical customers have churned, yes or no. We can now use this data set to build an analytical model, like a decision tree, which we can then use on our future population of customers. And you can use any type of software. You can use commercial software like SAS, like SPSS, or open source software like R or Python or Julia, which is also getting very popular, to build an analytical model. To the right, bottom right, you can see an example of a decision tree, which is an analytical model. It tells me that if the age is less than 40, yes, and the frequency is less than 5, yes, then the customer will churn. That's what it tells me. It's a decision tree, and that makes it a very interpretable model, right? It's very easy to interpret, and that makes it also very attractive. But note, however, that it is an analytical model. That means that not everybody whose age is less than 40 and frequency is less than 5 will churn. The majority of those customers will churn, but not everybody. It remains a statistical model. Hang on. Various types of analytics can be thought of, and a common distinction is between predictive and descriptive analytics. In predictive analytics, you want to predict the future based upon the past, and you always have a target variable. Think about the examples we already clarified on churn prediction or response modeling. In churn prediction, we have a target variable, churn, yes or no. In response modeling, likewise, response, yes or no. If we would do customer lifetime value modeling, CLV modeling, then our target will be continuous. That's also an example of predictive analytics. More specifically, that's an example of regression. In descriptive analytics, we do not have any target variable. So we just have a bunch of data elements or variables, And one of the examples of descriptive analytics could be clustering. That means that you want to find homogeneous subsegments within a group of customers. You could cluster your customers based upon your RFM variables, for example. You can look at segments of customers with high recency, high frequency, and high monetary values. That could be a very valuable segment of customers because those customers purchase a lot and typically for high amounts. Other types of descriptive analytics can also be thought of like association rules, like finding associations between your product purchases. This is exactly what Amazon does. When you go on an Amazon, if you would purchase my book, for example, you will see that, or if you just look at my book, you don't have to purchase it. But if you just look at my book on analytics in a big data world, you will see what other products have been bought together with my book, which kind of is the foundation of the recommendation system adopted by Amazon. When you look at analytical models, various model requirements are important depending upon the setting in which you deploy your analytical models. First one is business relevance. Your analytical model should solve your business problem. If your business problem is detecting churn, then your analytical model must be configured and built in such a way that it actually detects churn. And it should do that in a statistically meaningful way. So statistical performance is another important relevant requirement. The patterns which are detected by your analytical model should make sense statistically, right? So that's why churn models will be characterized by lift, fraud models will be characterized by hit rate, segmentation models will be characterized by separation measures like F statistics, etc. So the patterns must make sense from a statistical perspective. And then we have interpretability, which is also very important. And interpretability highly depends upon the setting you work in. If you think about complex analytical techniques like neural networks, those are totally not interpretable. They are powerful, but not interpretable. That means that we cannot use neural networks in very mission-critical applications like credit risk modeling. Although neural networks can be very meaningful for credit risk modeling and highly performing, we cannot use them because they are essentially black box techniques. In other applications, like response modeling, for example, the need for interpretability is less of a concern. That means that neural networks can easily be used to build response models because maybe we're only interested in knowing who will respond to our marketing campaign rather than why they are responding. Operational efficiency is also very important. Think about credit card fraud detection. If you do credit card fraud detection, as soon as you initiate a credit card transaction, you only have a few seconds to decide whether the transaction is fraudulent, yes or no. So that means that you cannot wait for minutes or hours and hours in order to label a transaction as fraudulent, yes or no. And then we have the economical cost. How much does it cost us to build the model and evaluate it and run the model, for example? Think about also the importance of external data. External data these days is getting very important to boost the performance of your analytical models, but yet it comes at a price. Right? So that means that you have to factor in the economical cost in the evaluation of your analytical model. And when you think about cost, total cost of ownership is usually not that hard to define for your analytical model. But what's a lot harder is the return on investment, or ROI. And finally, given that analytics more and more permeates everything in our daily lives, we see more and more regulation popping up. In Europe, for example, we have the GDPR, which is the General Data Protection Regulation, initiated by European institutions, that kind of comes up with guidelines in terms of privacy, like what data can we use from our customers to do what? How should we make sure that our customers are given good disclosure about what we do with their data? Well, what about the right to be forgotten, right? If a customer asks to be forgotten data-wise, such that there are no more data tracks of this customer, how should we accommodate that? So you see that an analytical model is doing more than providing good statistical performance. There are various criteria or requirements that it should satisfy. Plus, Processing means that we're going to then interpret and validate the analytical model and also deploy it in our business applications. When we deploy a model in our business applications, sometimes we will have to represent it in an attractive way. One of the things that is getting very popular these days is the role of visual analytics. And that's something that I will elaborate on in a few minutes. The goal of visual analytics is to bridge the gap between analytics as a technical discipline and analytics as a value-adding business activity. And face it, analytics is a very complex exercise. And in order to bridge that gap, in order to make it more accessible to a wide audience, including decision makers and top managers, visual analytics will be very important. That's why visual analytics can basically be used to solve two analytical disconnects, as I would refer to them. First of all, you have a disconnect between the data and the data scientist. If you look at your company data, you'll see that your data is unstructured, distributed, noisy, time evolving. The data scientist, on the other hand, wants to take that unstructured, distributed, noisy, and time evolving data and look for patterns in it. He will look for statistical significance, predictive power, and try to structure the unstructured. That disconnect can be solved using visual analytics, as we will see in a moment. But that's not the only analytical disconnect. We also have an analytical disconnect between the data scientist and the business expert, because as a data scientist, and I consider myself as a data scientist, we think in terms of decision trees, neural networks, logistic regression, random forests, area under RC curve, hit rates, top decile, R-squared, etc. Terms and techniques which are pretty meaningless to decision makers, business users, managers, people that actually have to rely on these analytical models and use them. Because those business experts or decision makers think in terms of customers, marketing campaigns, risk mitigation, portfolios, profit, return on investment, etc. This particular analytical disconnect can be bridged using visual analytics as a mediator. Here you can see some examples of visual analytics in the early days, long time ago, because that's a very interesting map we see right here. You still remember that Napoleon invaded Russia in 1812. He did that because Russia was not interested in participating in the trade embargo against the UK. Napoleon decided to invade Russia, and here you can see actually how he did that in terms of troop size. So you can see the thickness of the brown line at the beginning indicates the start of the campaign, and the thickness of the brown line is actually the size, the amount of troops. And you can see as he came closer to Moscow that the troop size, obviously the size of the soldiers of the troop size actually decreased, because the Russians were adopting the technique of the torched earth, which means that they burned everything they left behind. And then you can also see in black the size of his army when he retreated. You can see that's a very attractive visual because it tells you how many troops were where, when. It also includes the dates, it also includes the temperature at the bottom, and so on. So it's just one visual, but with a tremendous amount of information in there. This type of visualization mechanisms that we also would like to use in analytics to bridge the gap between the data and the data scientist on the one hand, and the data scientist and the business user on the other hand. This visualization and the way this can be done depends upon what stage you are in your analytical process model, as we outlined it before. Data pre-processing step, you can use visual analytics to find outliers, to look at values like age is 200 years old, but also to find missing values, frequent, suspicious, interesting patterns, etc. Visualization is the first important thing, right? To understand your data, to do exploratory data analysis. And basically what you do here is you take data as your visualization unit, and you're going to look at histograms, you're going to look at scatter plots, you're going to look at box plots. There are various types of plots, even pie charts, bar charts, to actually get to know your data a little bit better. And that's a very important step, which is not to be forgotten. But once you have passed that step and you started building your first models, use visual analytics to represent your models in a user-friendly way. So here, the visualization unit will be the model formula. Visualization can also be very usefully adopted when you start using your models, because maybe you're interested in combining your analytical model with a geographical information system and see, for example, whether responders are geographically distributed in different ways, whether fraudsters are geographically distributed in different ways, whether defaulters. If we look at corporate bankruptcies in Belgium, for example, you can see certain regions in Belgium, certain geographical regions that have more bankrupt firms than others. That's something you can figure out by combining an analytical model with a geographical information system. And then we have model backtesting, which means that you're going to contrast your model you're going to contrast the model predictions against the outcome to fully understand when your model starts to degrade in performance. Also here, visual analytics can play a very important role. Let's clarify each of these with some examples. Here you can see a cluster plot, which is actually showing us correlations between exchange rates of currency amounts. It's something I borrowed from the website indicated below. So you can see it's basically a matrix showing you the correlation each of those currency rates. The correlation is indicated in each of the squares, and it's colored. The bigger the correlation, the greener the colors. So you can see that negative correlations are indicated in red colors, orange colors, and some yellow colors as well. This is in the upper half of this matrix. In the lower half of this matrix, you can see the scatter plots, because a correlation is only one summarization. It's a summarization measure. In the lower half, you can see the scatter plots, which gives you a little bit more insight into how the pattern really looks like. Matrix, you can see a clustering. That's a result of a hierarchical clustering, and essentially what it displays is a histogram whereby similar currencies are clustered. So you can see there's a tremendous amount of information in this one visual, which is also very actionable. It gives you good insights. In terms of model representation, you can look at scorecards, for example. And you guys in the US, because I think that most of you are from the US, you're very well sophisticated in terms of scorecard development. You're more sophisticated than we are in Belgium or even in Europe. So to the left here, you can see a logistic regression model. Logistic regression is one of the most popular models used in the industry nowadays. It's being used for credit scoring, it's being used for churn prediction, it's being used for fraud detection, and so on. Model, despite being pretty straightforward from a statistical perspective, is not that evident to be used by a decision maker who is not familiar with any type of statistics. This logistic regression model that you can see to the left can be perfectly mapped to a scorecard, which you can see to the right. So in terms of performance, in terms of statistical significance and statistical evaluation, logistic regression model to the left is perfectly equivalent to the scorecard to the right. The only thing is that the scorecard to the right gives me a lot more insight into what are the important characteristics for credit scoring and how do they relatively compare to one another. And there exist mechanisms, for example, I discussed this in my book, to translate the logistic regression model of the left to the scorecard on the right. Another very exciting way to visualize a logistic regression is by using nomograms. You can see that's something I kind of bumped into quite recently. You can see a logistic regression model visualized nomogram. And a nomogram is a colored scheme that tells us how much every variable contributes to the overall score. So at the bottom of my nomogram, you can see the score of the risk of having a heart attack. So the probability of having a heart attack ranges from 0 to 0.75. See the bottom of my slide. And that probability is affected by age, systolic blood pressure, diabetes, and prior stroke of or whether you had a prior stroke, yes or no. Right? So you can see that if you did not have a prior stroke, right, it's very dark green, so the risk of having another stroke is lower than if you had a prior stroke. You can also look at people that had diabetes are more likely to have a new stroke than people who did not have diabetes. The higher your systolic blood pressure, the more likely you are to have a heart attack. The older you become, the more likely you are to have a heart attack. Females are more risky than males. So these are just straightforward insights that you get from these nomograms. And a nomogram is a very nice way of visualizing this logistic regression model. Now, what about if you're working with rules? Think about if-then rules, for example. Here you can see some rules. You can only have 4 rules, and there are 4 rules. Let's not use a lot of rules. Let's not make it overly complex. We have 4 rules that are being used for churn prediction. So if the average usage of your phone is less than 25, and you don't have any internet, and you have in the international plan, and you make more than 3 service calls, then you're most likely to churn. 1. Second rule is another rule, and then we have a third and a fourth rule. There are only 4 rules, right? And rules are supposed to be quite interpretable, quite comprehensible. But can we see any rule conflicts? Are there any situations where we have both churn and no churn? Do the rules provide exhaustive coverage? In other words, do they cover any possible combination of variables? That's not that evident to determine by looking at these 4 rules. If you would visualize it in an alternative way, if you adopt visual analytics and you visualize it as a decision table, patterns that we're looking for emerge. Here you can see a decision table. So it's a top-down evaluation structure. It represented in a tabular format. So we start by looking at average usage, less than 25, bigger than or equal to 25. Let's say it's bigger than or equal to 25. Now we look at international plan, yes or no. Let's say that is yes. Service calls, less than or equal to 3 or bigger than 3. Let's say it's bigger than 3. So we basically follow this path, and then we see not churn. So what we've done is we've taken those rules and represented them in a decision table. And then immediately you can see all the anomalies pop up. You can see that we have rules R2 and R4 right here, which provide us with conflicting decisions. So one rule says churn, the other says non-churn. Apparently, this cannot be, right? This is a conflict. Whereas here we have a region where none of the rules fires. So in case the average usage is bigger than or equal to 25, no. And service calls is either less than or equal to 3 or 3, then nothing happens. So you can see that in those 4 rules, by using visual analytics and representing it in another way using decision tables, we can see that we have a conflict here and we do not have any coverage here, which is not nice. Visual analytics can also be used during model usage. As I already said, visual analytics can be used together with a geographical information system, or GIS, to understand geographical patterns in your analytical models, to see where most of your churners live, to see where most of your responders live, etc. Right? And there exist all kinds of very nice tools to do that, like SAS Visual Analytics or Tableau are 2 common names here. Those visual analytics during model usage should also support segmentation of your users. And here you can see a segmentation exercise as it can be conducted using Google Analytics. And I looked at, for example, people that were returning users or new users on my website. So I have 2 segments, returning users, new users. Ideally, an analytics tool during its usage should also allow you to do segmentation of users in any possible way that you would like to look at your users and your customers, etc. Segmentation or visual analytics also has its role to play during backtesting model monitoring. That means that you're going to monitor your models and backtest the outcome of your models. That means the prediction of your models with the realized outcomes. Here you can see an example in credit risk modeling, for example, whereby at the top of this table, you can see the predicted default rates or the predicted probabilities of default indicated in blue. And then next rows indicate the realized default rates, what you predicted. And here, from 1993 onwards, you see the numbers as they really occurred. And obviously, you want your predictions to be as close as possible to reality. We can use visual analytics to help us decide upon how good our model is doing. Like green could mean like we're close enough, that's fine. Yellow could mean we're too far off. Orange could mean we're really far off. And red could mean we're actually too far away from our prediction. So by appropriately, adequately coloring this table using visual analytics, we can immediately see where and when the problems start. So we have a first problem in rating B2 right here, and then we start seeing problems from 2001 onwards. Obviously, as you operationalize this traffic light indicator approach, there are various things that you have to decide upon. You have to decide upon the number of traffic lights, the color coding, and so on. And it all boils down to statistics. Right? There exist various statistics which basically are going to underline this table, right? So in some of my courses, because we teach quite a bit of courses, we zoom into the binomial test, we zoom into high score test, normal test, which can be used to actually build this kind of model backtesting tables and then visualize them afterwards using visual analytics based upon the significance level of each of those tests. Temporal patterns are also very nice to visualize. So here you can see an exercise that we did, a piece of research on churn prediction in telco. Right? So churn prediction in telco, one of the topics that we have been working on is social network analysis for churn prediction in telco. So we looked at call graphs, we looked at who calls who, right? If Bart calls Peter and Bob quite often, then together we make up a social network. That could have very important effects in terms of churn, because if Bart churns, maybe Peter and Bob will also churn. That's what we call a viral or social network effect. And you can visualize that using a very simple graph, for example. In what follows, I'm going to click this, and you will see an animation that starts, that builds a network of customers, whereby the blue customers, let's see whether this works, I think it works, where the blue customers are customers, and the red customers are churners, as you can see them in time. You can see people churning in time. Moving into a sub-fragment of this graph, you can see from a certain point onwards, and I cannot pause this thing, that you can see people churning quite close to each other, which clearly indicates a social network effect, meaning that most likely one person influenced the other person. So we're going to zoom into parts of networks. You can see here people churning. Here you can see a whole chain of people churning. Do you see that chain? Which clearly indicates a viral effect, which clearly indicates that there could be mobile phone, excuse me, which clearly indicates a viral effect in the graph, right? So to conclude this webinar, and I still have some things which I would like to show you, it's really important that you are very critical about emerging technologies such as deep learning, for example. Because why? Because I said that many of those technologies are predominantly focused on very high accuracy, rather than some of these other criteria that we have been talking about, like interpretability, like operational efficiency, like economical cost, like regulatory compliance, and business relevance. Very important is that you validate your patterns. If you look at newer technologies like deep learning, they are very sensitive to overfitting, but although there exist mechanisms to counter that, it's really important that your patterns, the models that you develop, are properly validated. And obviously, since all of you are working with firms, at the end of the day, it's the bottom line impact which is going to matter. So profit-driven analytics, whereby we also look at total cost of ownership and the return that an analytical model will give us, are very important concepts. Throughout this webinar, I also very much stress the importance of visual analytics. Visual analytics as a mechanism, as a set of tools that allows you to bridge the gap between the data and the data scientists on the one hand, and the data scientist and the business user on the other hand. Now, before I can take some of your questions, I'm happy to refer to some of the courses that we often teach worldwide. We're actually teaching some of them at this very moment. Although all my courses are organized in collaboration with SAS, they all focus on concepts, methodology, and not on the software. So on average, about 1/3 of my course participants use SAS, whereas some of the others also use R and Python and so on. And we kind of have courses on intro courses to analytics. We have advanced analytics courses, credit risk modeling, and also fraud analytics courses spanning multiple days. We teach those on site, but given the request, we also have e-learning versions thereof. And here you can see an e-learning version of my advanced analytics course in a big data world. And I would like to give you a very small demo of that. My e-learning courses are basically all a set of videos. That means that you can start whenever you like. It's not one-to-one lecturing in the sense that I have to be live and you have to be live at the same time. It's a set of pre-recorded videos, is analytics-related issues depending upon the course that you follow. Here you can see my advanced analytics in a big data world course, for example. So I'm going to click start course, right? And here you can see all the lessons. So we have the analytics process model, which goes into a little bit more detail than what I did a few minutes ago. I have a lesson on decision trees, random forest, etc. I have a lesson on neural networks, and each of those lessons has various movies. A movie is 2 to 3 minutes, right? So here you can see in neural networks, we explain about multi-layer perceptrons, about how to train the networks, how to open up the neural network black box, because as I told you, neural networks are black box techniques. It's very hard to understand how they work. Well, in this section, we're going to explain how you can extract rules from them, how you can do input selection, and how you can use them in a two-stage setup. Self-organizing maps for clustering. The course focuses on the concepts. Occasionally, we have demos. So every now and then, you will see a SAS demo, like here, how to estimate neural networks in SAS. If you're not a SAS fan or a SAS user, you can skip those. I also have a lecture or a lesson on support vector machines, Bayesian networks, which are very important if you ask me, because they're probabilistic white box classifiers. Survival analysis, which is also another important set of analytical techniques which focus on predicting the timing of events. So you're going to predict when a customer is going to churn, when a customer is going to respond, when a customer is going to default, rather than if a customer is going to churn, if a customer is going to default. Networks, when we say social networks, we're not referring to Facebook or Twitter, but we're referring to any type of network where people are connected in a particular way. That could be using CDR data called detail records. That could be links between firms, links between claimants, etc. If you look at our social network lecture, for example, you will see that we start from applications of social networks and give you an overview. So I will quickly show you like how the videos look like, right?
In this lesson, we will discuss how to leverage social networks for analytical purposes. Obviously, when we say social...
So this is an example of a movie, right? You can fast forward it. It also has closed captions, so you can just...
people and the edges represent email exchanges.
It starts from a very basic background knowledge, so there's not any type of advanced statistics that you have to take this class. We also have various case studies, like here is a case study on Gotcha, which is an in-house fraud detection mechanism that we detected, that we actually developed, and which we also extensively cover in this e-learning course. Also a section on monitoring analytical models. All the videos are mixed with quizzes, so here you can see a quiz, and at the end of the e-learning, you also get a certificate, right? You can get a course certificate. So I have those e-learnings on 3 different types of topics. As you can see here, I have one on advanced analytics, right? Let me just... I have one on advanced analytics. I have one on fraud analytics, which is my most recent one. and I have one on credit risk modeling for those of you that would be interested in credit risk modeling. So don't hesitate to let me know in case you have any further information on those courses. Hui told me that I should aim at 50 minutes. I think I'm almost there. I'm 50 minutes right now. So I have some time to take some of your questions.
Yeah, thank you, Bart. Now
ready to take some of your questions.
Yep. First, Bart, can you make your slides available?
What
there
do you
are a
want
lot
me
of
to do?
information for people to write it down. Make the slides available. Can you make your slides available?
Yeah, sure. I can send
your
them around.
presentation, the slides, the material. Okay.
Yeah, you can have my slides. That's perfect. Yeah.
Okay. Yep. First question, you talk about the social network analysis. There's question on the data because you also talk about the privacy policy.
Yeah.
And how to get those social network data, and how to hook the data up to the actual behavior, because there's usually again social and the behavior towards the purchasing.
Social network data you do not have easily available in every setting. There are a few settings in which you can think of social network data. First of all, telco and churn prediction, where you have CDR data available, like who calls who. So there it's really straightforward to build a social network. We have also looked at fraud detection in our research, where we looked at tax evasion and looked at social networks between firms. And a social network could be any members of the board which are shared, any logistics which are shared, any employees which have been working at previous firms before. We also look at social networks in insurance claim fraud, where we look at networks between cars and people, between cars and car repair shops, between people and mobile phones. So there the social network structure is readily available. I do agree that you do not have that in every possible setting. To come back on your privacy viewpoint, obviously it's really important that the privacy is always respected, especially within a context of GDPR, and the customer is given a good information about what type of data is being collected and how it's being analyzed. And by doing so, it's not only important to dangers of the technology, but also to look at the potential of the technology, because if technology could help avoid my credit card being used for fraudulent transactions using social networks, I may be tempted to have my data used for that purpose as well.
Another question is, do you think big data will replace traditional marketing survey one day? Since there are so many data.
Replace traditional what? Will replace
marketing survey.
Traditional marketing.
Marketing survey data.
No, I think no. I don't think it's one or the other. I think it's both. I mean, market surveys are also still a valuable instrument. I think it's just a combination. I don't think big data will replace a lot of other ways of doing and collecting data or analyzing data. It's just, I mean, it's just a complement. It's just a very nice add-on. So it's not one or the other, but it's one and the other.
There are a lot of data floating around. Do you have any guide rule for what kind of data we should collect, what kind of data we shouldn't collect? There's just too many.
But depends. I need to know the business area you're working on, and also the analytical problem you would like to solve. If you'd like to do churn or response or customer segmentation, I mean, usually the more data you can collect, the better, because then your analytical model will tell you what is the relevant data and what not.
Is there any model that can do causal inference right now? If it's predictive, maybe it's more focused on accuracy. If it's pattern recognition, it's more descriptive.
Yep.
But in business world, most of the time we want to know the reason.
Well, there exists a very exciting set of models which are called graphical models, and popular examples of that are, for example, Bayesian networks. And Bayesian networks are very good at causal inference, at looking what variable or what change in a variable has a causal impact on another variable, right? So I can, if you're really into causal patterns and causal relationships, I can refer you to graphical models such as Bayesian networks.
How to justify return of investment for analytics in the business world?
Justify, well, often
the
justify
leaders.
means that it's ex post, but I think anticipating return on analytics and having very precise numbers, as with any investment, is very hard. There are a couple of surveys online, some of which have been run on KD Nuggets, for example, that report return on investment of analytical projects for various types of analytics. So if you're investing, you can look at those, or if you have to make investment decision, you can look at those numbers as a reference benchmark. But as I told you, it's really hard. That's part of the risk of investing in analytics. The only thing I can tell you is that the majority, a big majority of firms that have invested in analytics have found very big ROI values for it.
Do you think big data is overhyped?
That's a good question. I don't, well, yeah. I mean, it has its potential. So I think the hype is there. I do agree that the hype is enormous right now. Everybody wants to jump on the big data bandwagon, but it has its potential. I'm convinced that there's a tremendous amount of customer knowledge hidden in your big data sources. So I think it's relevant to spend attention to it, to use it, to leverage it, but obviously in a sound way.
Is there any decision you think cannot be supported by data? It seems data can do everything. Do you think there's some kind of decision that cannot be supported by data, has to be
Personally, I think real causal inferencing, I mean, despite the fact that there are some techniques available to do so, I think real causal inferencing is still a big challenge for analytics. And I think human experts will still be better than that, than pure analytical techniques. Although the latter can be used as an aid, but I mean, humans, I think, are still better than that.
If an organization want to move towards analytical decision, what's gonna be the biggest challenge if they don't have the history of being analytical data-driven? For some traditional companies.
Trust is the biggest challenge. Data and trust.
Okay.
Find the data and generate trust in analytics. Those are the biggest challenges.
See if we have further questions. Anyway.
Yeah, lots of questions.
I think that's all for today.
We done?
Yep, I think that's all for today. Thank you, Bart. We will make the slides available so you will know the material Bart has shared to you, the links.
Great. Thanks, everybody. Thanks for attending. Bye-bye.
Thank you, everyone. Bye.
Bye.